Today's topic for discussion for chemistry of class 12 science is nucleophilic addition of ammonia and its derivatives to carbonyl compound. So let's begin with the discussion first with ammonia and its derivatives. So as we all know, the formula for ammonia is NH3, which can also be written as NH2H. So you must be having a curiosity in your mind regarding ammonia derivative. So you don't have to worry about ammonia derivative because these are derived from ammonia whenever one of the hydrogen of ammonia is substituted with any other group, say Z. Okay, this Z is any other group regardless of hydrogen. Now, in your ISS syllabus, there are 5 different types of ammonia derivatives. So let's discuss about these derivatives one by one. So, in the first place, we have hydroxylamine. So, in hydroxylamine, this Z group is replaced with OH group. So whenever this Z group is replaced with OH group, then we get our first derivative of ammonia, that is hydroxylamine, and whose formula is NH2OH. Now moving to the second derivative of ammonia. The second derivative of ammonia is hydrazine. So in hydrazine, this Z group is replaced with another NH2 group. So let me repeat you once again. What is hydrazine? In hydrazine, this Z group is replaced by NH2 group. And whenever we have this formula NH2, that gives us what? Hydrogen. Now, please students, look at this formula of hydrogen carefully and remember it. Why? Because the next 3 derivatives of ammonia can be obtained from this hydrogen formula. So let's do that. The third derivative of ammonia is phenyl hydrazine. Phenyl hydrazine. So you can see here in the third derivative we have the name hydrazine present here. So in the second derivative we have already known the formula of what? NH2. NH2 is the formula of hydrazine. So let me write that first. NH2, NH2. Now this is the formula for hydrogen. Now what is added in the third derivative? The phenyl group. So in phenyl hydrazine, one of the hydrogen is replaced with phenyl ring. Now see how this name of this compound is phenyl hydrazine? Because from hydrazine, one of the hydrogen is substituted with phenyl ring. Therefore, its name is phenyl hydrazine and is the third derivative of ammonia. Now, moving to the fourth derivative of ammonia, we have 2,4 dinitro phenyl hydrazine. So here the fourth derivative contains the name phenyl hydrazine, which was our third derivative. So let me write the structure here for phenyl hydrazine. So it is NH2, NH, and the phenyl ring. Now what is extra in the fourth derivative? In the fourth derivative, we have at 2 and 4 position of the phenyl ring, which group we have? We have nitro group. So as you know, this is the first carbon, second carbon, this is the third carbon and the fourth carbon. So at second and fourth carbon, which group we have? We have nitro group. Therefore, at second position and fourth position of this phenyl ring, we will be having what? Nitro group. And this is the formula for fourth derivative of ammonia, which is 2,4 dinitrophenyl hydrazine. Now, moving to the last member of ammonia derivative. The last member of ammonia derivative is semi-carbazide. So this is also can be obtained from the formula of hydrazine, as I told you. Now, first let's write the formula for hydrazine here also. Now, in this case, in semi-carbazide, the hydrogen of this NH2 group is replaced with amide group. Amide group is what? C double bond O NH2. This is the amide group. Whenever this amide group replaces one of the hydrogen of hydrogen, then that gives us the fifth and the final member of our ammonia derivative, which is semi-carbazide. So, my dear students, please, you have to remember the name of all of this ammonia derivative along with their structures. And one thing you can see in common in ammonia as well as all the ammonia derivative, we have this NH2 group in common. We have this NH2 group in common. Okay, and this is the reactive part of these compounds, which takes part in nucleophilic addition reaction. Moving to the next section of our discussion today, we will be doing the reaction of carbonyl compound with ammonia and its derivatives. So we can get the product of carbonyl compound with ammonia derivative, which is generally represented by NH2Z, in just one single step. So this reaction takes place in slightly acidic medium. That means H+ ions are present in the solution. Now for this, the pH value has to be maintained between 3 and 4. Now if you want to predict the product in just one single step, we can do that by eliminating a molecule of water from this reaction, and whatever is left in the reactant of these two compounds, we have to write them together in one condensed form. So here in this part, this double bond C double bond is left. Now this will be condensed with nitrogen of this ammonia derivative part. So this carbon double bond is bonded with what? With nitrogen. So this is the product that we obtain, and here please students have a look at this one. Here carbon is doubly bonded with nitrogen, and this category of compound is known as imines. They are known as imines. Now, since mechanism is also there in your syllabus, so let's discuss with the mechanism of nucleophilic addition reaction of ammonia and its derivatives to carbonyl compound. So this is the carbonyl compound. This is the carbonyl compound. Since this takes place in acidic medium, we have H+ ion readily available in the solution. Oxygen contains 2 lone pairs. Now this H+ acidic medium is a must for this reaction to take place. Why? Because it helps in initiating the reaction. This is negatively charged. This lone pair means it is equivalent to the negative charge. This will be attracted to the positive charge. As a result of that, we would be getting a carbocation. So here we have OH bonded with carbon of the carbonyl compound. Here the valency of carbon is unsatisfied, therefore it has a positive sign over there. As a result, we get a carbocation. Now, in the next step of this mechanism, nucleophilic addition reaction takes place. Now here NH2Z is acting as what? Nucleophile. So here NH2Z, nitrogen also contains a lone pair. Now this lone pair is attracted to this carbon center. As I told you here, this lone pair is equivalent to a negative sign. Now once this approaches this carbon center, then nucleophilic addition reaction has taken place. Okay? So here let me write the product obtained after this addition reaction. Nitrogen, here we have two hydrogen. I am writing them separately so that the valency of carbon, the valency of nitrogen would be understood. You know, nitrogen at the most can form 3 bonds. But here in this compound, you can see it has formed 1, 2, 3 and 4 bonds. As a result of that, it has a positive sign over nitrogen. Okay? Now in the next step, the valency of this nitrogen has to be maintained. Therefore, to maintain that this valency of nitrogen, this hydrogen sacrifices its electron and it gives its electron to the nitrogen. So as a result, we get a compound where we have N, H and Z. And as you know, this already contains a lone pair of electrons. Now in the next step, since I told you this is taking place in acidic medium, protons are already available in the solution. Now again, this lone pair of oxygen, which is equivalent to a negative charge, will be bonded with this proton. So as a result, we get another compound in which oxygen has a positive charge and have a look at this one. This is H, 2H is bonded with oxygen and this is H2O. And you know H2O is a very easily leaving group. As a result of this water molecule leaves this compound. Now let me write this reaction here now. Here we have nitrogen, hydrogen and Z. Now once this water molecule leaves, a positive charge is developed over. So once this water molecule leaves this compound, a positive charge is developed over this carbon and which is very unstable. Now as a result of that, this hydrogen, it sacrifices its electron and it forms a double bond between this carbon and nitrogen. And as a result, we obtain the desired product of this reaction, that is NZ. And this is imine. Now, I request you to go through this mechanism properly, because if it's asked in your ISC, then you should be able to do it. Now see, here, this I took the general derivative of ammonia. Now same mechanism can be applied for ammonia as well as all the 5 derivatives of ammonia. What you have to do, if suppose this was ammonia, then in place of Z, what would be there? Hydrogen would be there, and you would be getting the product. Your product would contain, instead of Z, it would contain hydrogen. Similarly, if it was hydroxylamine, then it would be, this Z would be replaced by OH, and in your end product, in place of Z, you would be getting OH. Similarly, the same mechanism is for all derivatives of ammonia, but one exception is there. Now this mechanism is followed by all the carbonyl compounds except formaldehyde. Now for formaldehyde, this product, this one-step product, and this mechanism is not followed by formaldehyde. Hope this was helpful for you to understand this mechanism of this addition reaction of ammonia and its derivatives to carbonyl compound. Now, I would ask you to solve your IC questions which are present at the end of this chapter, and if there is any doubt, as we have already made one WhatsApp group, so you can ask me in that, or you can personally call me, since you all have my number. Stay safe, take care, see you in next video.